right. So Jess Newley is the Community Science and Education Director for the Friends of the San Juans. And before working in San Juan Islands, she's, well, and I'm sure still is, a scuba diver instructor. She's been in Egypt. She's taught kids marine science from a sailboat all over the Salish Sea, sailed her own boat across the Pacific Ocean, lots of underwater photography, a deep passion for the marine environment. And we are really happy to have her here and celebrating with us the theme for tonight, which is our love of the Salish Sea. And that is the title of her talk, Why We Love the Salish Sea. Over to you, Jess.
Awesome. Thank you, Anne. Thank you, Deborah, and all the organizers for having me. It's a real pleasure to be with you all tonight and be kicking off this very exciting, wonderful event and gathering of educators and learners and passionate community members of this place that we all love and want to learn more about and be inspired by. I am going to share my screen. So tonight, before we get started, I was just wondering if you all do a little imagination exercise with me. So if you would, if you could all close your eyes with me for a second, for a moment. And we are going to travel back in time. Imagine yourself sitting on the shorelines of the Salish Sea 5,000 years ago. Behind you is an old-growth forest, the green canopy towering above, swaying in the wind. The tree trunk so big, you and 10 of your friends aren't able to link arms around to surround it. A group of migrating birds are moving back north in the thousands overhead. Their squawks are so loud you aren't able to hear anything else. In front of you, salmon are jumping out of the sea with reef nets set nearby, sustainably harvesting them, knowing that they will be there for the next generation and even the next 7 generations to come. There's some of that plentiful salmon smoking in a hut nearby. Breathe in, and as you take in that smell, your stomach grumbles with hunger. The people that are near you and around you share a special connection to nature. You're in a place where humans and nature coexist together in a relationship as one. Okay, you may open your eyes. Welcome back. There we go. Okay, and now I'm going to start with a little story, one of my favorite stories, and experiences scuba diving in the Salish Sea. I was on a dive just north of Seattle in the Edmonds Underwater Park, and I was swimming along and saw something move underneath a sunken little rowboat. And so I went to investigate, and what I stumbled upon was this giant Pacific octopus mom, a mother, and about her 30 to 50,000 eggs. And this is a moment in time that will stay with me forever, a moment connecting and witnessing this wildlife, this nature. And one of the reasons that was really special about it is realizing what was going on at this moment and imagining it in my mind. So octopus in the wild only live about 3 to 5 years, and they will die right after they reproduce. So this mom, what I witnessed is at the end near of her life stage, and she is doing all that she can to make sure the survival of that next generation. So you can see her tentacles, and even though this isn't video, you can imagine them moving. She's moving the water currents around the strands of eggs, and that's what's giving them oxygen, that moving water. And she has stopped all of her normal daily activities and routine just to continuously fight and protect those eggs. She stopped eating a long time ago. She's slowly giving her life for that future generation. If she moves from her nest, that lean cod nearby will come in and feast upon those eggs. And if she stops moving that water, they'll starve from oxygen. And again, it's moments like these shared with nature that has really got me hooked on spending time in the underwater world, cold water dive after cold water dive, and keeps me coming back. So the topic I was kind of given tonight, why we love the Salish Sea, got me really thinking of why I love the Salish Sea. And it's a really hard thing to answer, but I really appreciate the moment to reflect and kind of figure out those things. And I'm sure like many of you can resonate with, there's many things from the beautiful sunsets that we're about to experience tonight, exploring the shorelines and the emerald green and blue waters of the Salish Sea, the rich and diverse history and how lucky we are to have that connection here and to be able to learn from it. The recreational opportunities right outside our back door are endless. The rivers nearby that connect us all to the wider watershed, and the saltwater rivers too, the strong currents and tides that really feed into this dynamic system that bring all those nutrient-rich things and help create the biodiversity. And for me, really what it is, all those things, but it's being able to explore under the surface. It's diving through the bulk kelp canopies, learning more about this natural world and being in relation with it while learning about myself and growing with it and from it. So I like to share when I'm talking to students this photo, and because it really encompasses what I think is an issue with ocean and marine conservation. And that's the fact that it's really easy to look out over the Salish Sea or any ocean body of water and see a flat surface. And unless you're privileged like I am as a scuba diver and have the ability to train, to obtain the gear, make the investment, the time, the money, and all that it takes, it's really hard to imagine that wondrous world that's just under the surface, that we are all very much connected to, that depends on us and that we affect it. And so it has, and this place brings people from all around the world to help make those connections, which is awesome. How lucky we are to live in a place that people come from all over, and we get to experience from the humpbacks at the surface, breaching away, the orca whales going by, the playful sea lions on the rocks nearby, those beautiful anchorages that are so gorgeous and surreal, serene environment. I want to share a quote from one of my ocean heroes, I would say, and that's from Sylvia Earle, who said, "Knowing is the key to caring, and with caring there is hope that people will be motivated to take positive actions. They might not care even if they know, but they can't care if they're unaware." And for me, I started diving, scuba diving about 10 years ago. And it was very soon, it was when I was living in Egypt and being a scuba diving instructor, but it was soon after that it was hard for me to share all these things I was experiencing, and I wanted friends and family back home to know more and be able to see these things. So that's when I started doing underwater photography. And really that's been a journey of mine for the last 10 plus years, is doing underwater photography, sharing my stories and photos and strong imagery to help make that connection and make people aware of this world that I am super lucky to experience, and share that with students, with adults, community members, and through time, figure out ways to more and more share this world that I have fallen in love with and am so passionate about. And we live in the Salish Sea that is full of so many, oh, that doesn't, sorry, there we go. So many superlatives. Again, yeah, I've lived around the world in many places, and there's just nothing quite like the Salish Sea. It's home to some, again, this great superlative, like the largest octopus, which already made a cameo tonight, the giant Pacific octopus, largest octopus in the world. Some of the most beautiful reefs, with animals and plants on them. One of my favorite things about exploring the reefs in the Salish Sea is how you can see in that picture on the right, it's like that brown and green background, but then you have all of that life that really pops, that color is such a big contrast that it really pops and is vibrant. Some of the oddest or weirdest creatures, like this old grumpy looking old man, the wolf eel that come out of their holes to say hi. Another very weird creature that looks like it belongs in space or on Mars, this giant nudibranch. It's actually about that big. It's really a big nudibranch. Some of the oldest living fish, like the China rockfish on the left, and she's there with her eggs. That red bunch that you can see is her nest of eggs. Some of the coolest creatures, like this brittle star, basket star on the right, that looks like a plant, but is actually an animal. They extend those tentacles out into the water column to catch the food. And some of just the most beautiful scenery underwater, like we get to enjoy on land too. This is actually one of my favorite dive spots off Whidbey Island. I saw that somebody online is from Whidbey. And the crazy thing to think about is that, and I guess one of my favorite things about diving is that this is actually right near the ferry terminal. And so on surface, there's a lot going on. But especially when there's not a ferry leaving or coming or going, once I get under the surface, kind of everything becomes quiet. Everything calms down, and it's my peace. Some of the cutest little creatures. There's another nudibranch. Nudibranchs are one of my favorite things to find while diving. They're very, very colorful, and again, just that kind of contrast that pop out. Some other cute little fish too that remind me of like they should be in a Dr. Seuss book. Some of the most playful and curious, like I mentioned, the stellar sea lions. This is actually taken off of Vancouver Island, where I spent quite a bit of time diving with stellar sea lions. And it's like diving with a 800-pound puppy dog, like a Labrador retriever. And it's like, imagine coming home to a retriever and they jump all over you and want to play and investigate. That's what these stellar sea lions are like, but they don't have hands to investigate. And so they use their mouths, and they're rather large mouths with big teeth, which, yeah, can leave some big bruises, but it's a very fun interaction for sure. And some of the most iconic species that we get to enjoy, like the orca whales. And I'll admit, this is the only photo that's actually not from the Salish Sea. I took a trip to Norway on a boat last fall and got to go diving with orcas, the herring-eating orcas over in Norway. So I got to sneak in, but you don't get to get underwater orca pics very often. So I wanted to sneak this into this presentation. But this one is from here, and this is a transient orca whale that is hunting a harbor porpoise at the surface. And speaking of iconic species, Of course, we also have salmon. This is a spawning coho salmon in the Skagit River here in Washington State. And salmon are one of my most favorite things. You'll notice I say a lot of favorite things. It's hard for me to pick just one favorite thing. I pretty much enjoy any time under the water and in the water, sharing time with different species and habitats and wildlife. But salmon is definitely something that, yeah, I really am passionate about, spending time snorkeling with salmon in the rivers. And this picture is actually the very first time that I got to experience the salmon run. When I was in graduate school through Western Washington University, and I was up at the North Cascades National Park. And I saw a dead salmon on side of the riverbank, and being a smart graduate student, I was like, hey, if there's a dead salmon, there must be live salmon in the river. And so I went back the next weekend with all my dive gear, a dry suit, very cold water. And I investigated, and this is what I saw. And I couldn't believe my eyes. Yeah, no, I guess no pun intended. I was hooked on spending time with the salmon after this. This is also this is the pink salmon or humpy salmon run. And this is also, this particular time underwater was also one of those special moments that won't ever leave me. One of the females, found kind of, even though I was on the bank and away from most of them, she kept on coming to me and kept on swimming around my body. And I think she just found, I don't want to say comfort, but shelter or something, that she could use me to get a rest. And for me, it was special because it was the first time that I got a really close look at salmon, and I got to spend a lot of time with her and got close look at her scars, and really imagined all the things that she went through to get to that point, through the ocean, going back up the river, fighting hooks, fighting wildlife, eagles, bears, you name it. And so resilient, so much power. Another one of those mothers that is doing all that she can to get to where she's about to spawn, and she's barely has any energy. She can barely keep swimming, but I see her continue to fight up the river, knowing that, again, she's doing all she can for that next generation to spawn and keep them going. They're pretty powerful. And of course, salmon are so important for many, many reasons in this region, including culturally, people's way of life, economically. A lot of things depend on salmon, and they're so important, especially for those endangered southern resident killer whales, and so much more. And I am lucky to work for an organization that works to help support and protect, to sustain those iconic species like the salmon, like the killer whales, and the habitat that supports them. So and that organization is Friends of the San Juans. And so, as mentioned earlier, I'm the Community Science and Education Director. And our mission at Friends is to protect and restore the San Juan Islands and the Salish Sea for people and nature. And I just wanted to take a moment to show you all where I'm coming from today, which is the homelands and the territory of the Northern Strait Salish people. And the circle is where the San Juans are, if you aren't familiar. And I think many of you are from that imaginary line across the border, the Gulf Islands. I saw Vancouver and some Vancouver Island. And so I just kind of wanted to show we're kind of right in the middle of all that. And as I dive a little deeper into kind of the science and some data stuff and numbers, also like mentioned earlier, I am focused, and our information and data comes from the San Juan Islands, but obviously, and while those numbers might be focused there, the idea, the ecosystem extends beyond that imaginary border, and we all are one with this ecosystem. So something that makes the San Juan Islands a very special place, along with the Gulf Islands and other places in the Salish Sea with similar geography, is the marine shoreline environment. So just in the San Juans alone, we have over 400 islands, and it's that marine shoreline, so much marine shoreline. We actually have 407 miles. I don't know how many kilometers that is, sorry, of marine shoreline. That's more marine shoreline than anywhere else in the continental United States. And it's that habitat that really makes it a special place and supports so much biodiversity. And it's the reason why salmon are often coming through the islands in the Salish Sea. And whether we don't have like your big spawning rivers that are found on mainland, it's often we're very important for the juvenile salmon, the small salmon in the right-hand corner. So again, this picture and this data is San Juan specific, but it extends the same idea to the Gulf Islands and elsewhere. But it's that marine shoreline that creates rearing habitat for those juvenile Chinook salmon. So if you look at the arrows, those illustrate the amount of Chinook salmon that leave their natal rivers and head to the San Juan Islands for that rearing, which means to get big and strong before headed out to the Pacific Ocean. So you can see that a lot from the Fraser River, the Chinook salmon are coming down from the Fraser. And an interesting part of this picture is that there's even juvenile salmon coming from West Vancouver Island. So even though that they just have to pop out their back door to the Pacific Ocean, they kind of detour all the way to the San Juans and to that shoreline habitat that provides the protection so they can find the food and shelter they need. And again, so we're talking about the small juvenile salmon, and studies actually show that that is the most, like when you talk about salmon mortality and what point in their life stage they die off, this stage is the most important for survival of salmon. So as soon as the more food they find, the more stronger they get before the Pacific Ocean and their whole rest of their journey, the better chance of survival they have. And one of the big reasons why they're coming to the shoreline habitat is to find food, like forage fish. And forage fish or bait fish, small silver schooling fish that pretty much everything else depends on, including humans, but marine seabirds, other marine mammals, seals, porpoise, salmon, yeah, a lot of things. They depend on these small but very mighty fish. And there's quite a few different species of forage fish, from the Yukon to the surf smelt, and more, but I'm just going to focus on a couple of those this evening, like the Pacific herring. And this is a photo that I took on the west side of San Juan Island that really, and these are juvenile Pacific herring, and they're around, I figured out, they're around our shorelines all year round. So not just during spawning season, but all year round. It's like a highway, and I'm sure they're headed up to BC, and along everyone else's coasts that are here tonight. But they're cruising around this big marine highway, and they're very, very exciting to see. It's kind of all the life, kind comes out when those herring are around, from the birds and the seals and everything for the big feast. And herring need eelgrass to spawn, which it's spawning, as many of you probably know, season now. I know it's going off in BC. I've been seeing a lot of footage online. It's a very exciting time of the year. And another forage fish that I'm going to highlight tonight, mainly because it's the most important for the juvenile salmon, and that's the Pacific sand lance. And the reason why it is the most important for juvenile salmon is you can tell in that upper right-hand corner of the picture from NOAA, the shape of their body. So they're very long and slender. And this is going to be the sooner the juvenile salmon can go from eating plankton to eating other fish and getting protein, the better chance it has survival. And so that is why the sand lance is so important. And I've actually seen it with my own eyes and documented it. I don't have the footage here tonight, but so I showed you that video and the picture of the size of salmon we're talking about. It's about this big. They can actually eat a specific sand lance that's about that big, so just under its size. And it really, you wouldn't think it could even go down, but kind of slurps it down like that, and barely fits in. But that helps having that long, slender body to be able to fit in there. And obviously, a lot of other things depend on sand lance too, like that rhinoceros auklet with its mouth full heading back to its nest. And again, it's that nearshore habitat that it's so important for these fish. And you can see those as a photo of herring that is just under the surface of the island there. But this is, yeah, I love the nearshore habitat because it is where humans can directly interact with this wildlife in this environment, and have a direct impact and have a positive impact too, and learn ways for that. And there's so many elements to that nearshore habitat from land and under the water that you can't see. But pretty much everything, if you're walking along the beach, from the rocks to the driftwood, the trees that are providing shade, all of that is there for a reason and has a purpose, similar to under the water from the eelgrass and the bulk kelp, and the light coming in, all of it, which we're going to go into a little bit more. So eelgrass meadows, another one of my favorites. Eelgrass meadows are so beautiful to explore. It's like an underwater prairie. And again, I thought I had video of herring, but this is what herring depend on to spawn, and they really provide important nursery habitat for so many species, from Dungeness crab to the salmon and the juvenile salmon, flatfish, invertebrates, a lot of things. Again, find food and shelter in the eelgrass habitat. Couple cool things about them is that they're a flowering plant, so not an eel or a grass. But they need photosynthesis to grow. And so they grow, you can normally find it in 1 to 30 feet of water. And again, because that's where that light is coming through and hits. And there's many positive things for eelgrass, including stabilizing the shoreline, and it's a carbon sequester. Oh, there we go. And this is the adult herring in the middle of a spawn, which again is happening right now through the Salish Sea region. And yes, it is murky and milky because that is herring sperm that I'm swimming in to get this footage. And the weird thing is I actually couldn't see any fish at all because the visibility was so bad, but luckily the camera picked it up. Eelgrass, and again, this data is on this side of the border, but I'm sure it's the same story no matter where you are. Eelgrass is on the decline in many places. And specifically, if you look here in the San Juan Islands, we have a lot of red dots. So the red dots is where the eelgrass is on the decline. And this map is from the Department of Natural Resources here in the US. Green dots is from where it's increasing, and the gray is where there's no data. But it's always, you think in places like the San Juan Islands, like the Gulf Islands, places where it's pristine looking. We have these big tidals and currents that are flushing out fresh water, bringing it in and out. Some development, but not like a big city development. It's just, you'd think that we would, like, why is the eelgrass on the decline so bad? And we're doing a lot to research that and figure it out, but really, it's true no matter where you are that eelgrass has many pressures on it, including increasing water temperatures, and disease, infection, eelgrass wasting disease, docks. So any overhead docks that are built over the eelgrass, again, they need sunlight to grow, so that's going to shade them out and kill it off. Boat anchors is a big one. Every time a boat, again, that 1 to 30 feet of water is often also a very popular place to put your anchor when boating, and that can cause damage and pull the eelgrass out when people pull their anchor out. And then shoreline development. Ooh, bull kelp. And guess what? It's one of my favorite places to die. There's something about being in bull kelp, though, the bull kelp forest. Like you saw that little video clip of me diving down in it. But it really is an underwater forest, a place that I can explore and get to see the fish and wildlife in abundance, and again just kind of spurs my imagination for that relationship with nature, and what it must have been like so long ago. Bull kelp has a lot of cool facts. One of my favorite plants. It can grow up to 2 feet a day. It's one of the fastest growing plants out there, next to bamboo. It's also a place of refuge, food and shelter for so many species, including the herring, like seen in this picture, and the juvenile salmon. It also permanently removes CO2 from the atmosphere, and it actually sequesters 20 times more carbon per acre than land forest. And I like to imagine, really, it's what connects people, even if you live on way inland and can't even see the sea. Every breath you take in, you can thank bull kelp and the ocean for providing that oxygen. And a lot of those things, all those things that I talked about tonight depend on natural beaches. It's a really important thing to think about, and how, again, our life on land is directly affecting this underwater world. Those forage fish, especially the sand lance and surf smelt, they need natural beaches and sand. They lay their eggs on beaches. And so they come up when the tide is high and the water is high. They disperse their eggs and drops down to the sand. Of course, all the other things, the kelp, the eelgrass, natural beaches, and protecting natural beaches is huge. Friends of the San Juans, a lot of one part of the important work that we do is restoration. So this is an example in the restoration project we just completed on another island here, but you can see the bulkhead up top that was taken out. So bulkheads or hard armory is something that really deters or damages those natural processes that all those species and wildlife plants need in the environment. And I'd also just like to put a plug in there, I guess, or just point out that while restoration is great, and look at that bottom picture, back to its natural state, more or less, and still protecting the homes and but in a more natural way with dune grass and other native plants. It takes a lot of time and resources to do restoration. So that's my plug for protection first before restoration. Protecting our natural shorelines is very important. And there's so much we can do. I know I went a little dive on the issues and the pressures, but I've lived in a lot of places around the world and explored a lot of like tropical reefs and parts of the ocean all over, and it really is a resilient place. And kind of what I've seen happen and witnessed is if you even can take one of those pressures off of, things have a much better chance of coming back. So that's why, you look at eelgrass, and sure, we're not going to change water temperature, ocean acidification, and changing composition of the water, but we can go out and we can stop anchoring. It's something in water. It's something that we can control. And so kind of when we think about what can we be doing, it can be overwhelming to think about climate change and the stuff that's kind of out of our control, but think about in kind of stacks and increments of these pressures. And if we can even relieve the ocean, the Salish Sea, of one or two of these pressures that are in our control, it's resilient. She's very resilient, powerful being, and she'll come back. And so some of these things, and I've mentioned them, a couple of them already, but protect and restore critical habitat for salmon, for the forage fish, and all those things I mentioned tonight. Keeping beaches natural, build a rain garden. This is something I really like to get kids and students and community members excited about, whether it's at home or for the school, but anything that can naturally filter out runoff, especially stormwater runoff, and take out some of those pollutants and toxicants before they enter the Salish Sea is a huge help. Of course, anchor out of eelgrass. If you're a boater, if you have boating friends, spread the word. Friends of San Juans has some resources on our green boating webpage. In the San Juans, at least, we have mapped out where the eelgrass is, so boaters know where to anchor and where not to anchor, especially if you know it's a herring spawning zone. That's the critical, especially important to pay attention to. And then volunteer, tree plant, create that shade that all of these species need, beach cleanups. Think about every plastic water bottle is oil on the beach. This is something that we can really help, that kids love to help. Beach cleanups are easy things to partake in and do make a difference. And especially stay engaged and vote. That's a huge one. So before I end tonight, I want to take us all back to that place that we started in, to that place 5,000 years ago, where we coexisted and one with nature. And as we move forward, think about and just ask questions. What were the philosophies back then? What has changed? What did leadership look like? And what has leadership today gotten us, and the policies today gotten us to where we are? I encourage you all to question, what do we want to see going forward, and start making that change. And just like I said, that change really comes from one individual at a time. Small positive impacts make a big difference built up. And as I mentioned too earlier, I've been on this long journey of trying to connect people with this underwater world that I've gotten to know and love so much. And through that, I've kind of gone from photos to videos. And now, again, I have a pretty sweet job, but I get paid to do what I love to do, which is film underwater. And I've now found a new tool using 360 videos and virtual reality to share those stories and these experiences underwater with students and community members. And so I run a program called the Immersive Salish Sea program, where I go out in the field, I document scientists that are working to conserve and restore all of these things. And then, of course, the habitats, the forage fish, the eelgrass. I go up rivers with the salmon. And I get to take students with me underwater through VR headsets. And if you're interested, if you're a teacher or an educator and you're interested in how you can, for me, it's like I would love to take you all and every student out for a snorkel or a dive in the water to kind of experience that firsthand. But virtual reality technology is a really cool tool for education. Those kind of next best thing from that firsthand experience. And it's like a real life experience from the safety and warmth of a classroom or inside a house. So we just launched our website that has these 360 videos. Again, those pictures I showed tonight of the herring, of the bull kelp, of eelgrass, of the salmon, you can see it in the 360 videos on this website. And we just launched this website that is open access. So we're proud to offer these resources and tools free to you all if you want to share with students or other people and keep sharing those ocean stories and world with others. And that's all I have. So thank you all so much. I know that we have some time for questions. If you have any questions for me or want to reach out, please email me at jess@sanjuans.org, and I would be happy to connect with you all.
Thank you so much, Jess. That was amazing.
You're welcome. Thank
All
you.
your photos are absolutely gorgeous. They were so beautiful and make me want to get outside, even though it's cold, or not cold, sorry, now it's dark outside. But yeah, absolutely amazing. And yeah, I see some of the comments. Beautiful presentation, and it was informative and inspiring. And your photos, yeah, the photos are amazing. So I'd like to welcome Dilan Sunthareswaran, Natasha Buckiewicz, and Sadie Lye, who are students at UBC's Pelagic Ecosystems Laboratory. So Dilan and Sadie are in the second year of their master's program, and Natasha is in the first year of her PhD. In addition to giving some background about the oceanography of the Salish Sea, then talk about a new UBC research initiative called the Urban Oceans Project, which I know I'm very excited to hear about, being in oceanography. And there will be some time, as with Jess's presentation, there will be time for a few questions at the end of the presentation. So please enter these in the chat, and the host will moderate. So welcome, Dilan, Natasha, and Steve. And go ahead.
Thanks so much for that introduction. Yeah, let me just get the presentation set up here. Oh, whoops, actually, 1 second, sorry. Start, and then you just present your view, and then go back to the Zoom. And here, share screen. There we are. And on notes, we're here. So can you guys, everyone see the presentation as a presentation? Does it look like, or can you guys see our notes just to double check?
Looks good. We can't see your notes.
Okay, perfect. Thanks so much. I'll let Sadie get us going here.
Okay, awesome. Thank you so much for that introduction and for welcoming us here today to talk to you all. So as was mentioned, we're going to give a brief introduction to some of the oceanography of the Salish Sea and to our current research project, and talk about the urban environment in the Salish Sea. So just quick introductions. I'm Sadie. I'm a master's student.
I'm Dilan. I'm also a master's student here at UBC.
And I'm Natasha. I'm a first year PhD, and we are all part of the Pelagic Ecosystems lab here at UBC in oceanography.
So we're all going to present on the same computer, but we're going to pass it around. So if there's some jostling, I hope it doesn't disconcert anyone. So to get started, to give you a brief outline of where we're going. We're going to start with talking about the oceanography of the Salish Sea, the physical, chemical, and biological oceanography, and you'll get a little bit more familiar with those terms as we go on. And then in the second part of the talk, we're going to talk about the urban ocean in the Salish Sea. What is that? What are the characteristics and threats in an urbanized ocean, and some of our current research directions. So let's start in our place. I am lucky to work and play and live on the ancestral and unceded territory of the Musqueam, Squamish, and Tsleil-Waututh people, and I'm joining today from the UBC Point Grey campus. And the Salish Sea, as many of you are aware, was named for the language of the Coast Salish people who have stewarded and lived on this land for time immemorial. And I would like to acknowledge that. And this map here on the right is from that website that was shared at the beginning, and really does show how many different nations there are who have cared for this land. And so I encourage you to learn more about the nations of who you live and work and play on. And yeah, okay. Now for the oceanography. So starting with physical oceanography and the physical features of the Salish Sea. So the Salish Sea was primarily carved by glaciers, the last of which retreated 12,000 years ago. And this left shallow channels that left deep channels that reach 650 meters and more than 400 islands. So we see these really deep basins, these narrow passages, and then we have connection through the Strait of Georgia and the Strait of Juan de Fuca. And finally, there's a lot of rivers and rain entering the Salish Sea. And these four unique physical features create the circulation dynamics and the environment for the organisms and people that call this place home. So currents. Currents are what are moving the water around this basin, around the Salish Sea. And so we see weaker currents in the main body of the Strait of Georgia, up at the top of this figure, and then we see strong currents in the Strait of Juan de Fuca. And the interplay of these tides, coastal upwelling, and freshwater inputs are driving the water movement in the Salish Sea, which is then going to provide the right conditions for organisms to grow and thrive here. So, freshwater inputs. As I'm sure we're all aware, for those of us who live here, this region receives a lot of rain. And that's because we live in a rainforest. And that means that certain areas receive up to 6,000 millimeters of rain. Vancouver receives about 3,000 to 3,500 millimeters of rain, and Seattle receiving about 1,000 to 1,500 millimeters of rain annually. And that's a lot of rain, and all of that rain is going to end up in the ocean. The second major freshwater input is the Fraser River, and this is responsible for 46% of the freshwater entering the Salish Sea. So its plume is visible from space, as you can see in this picture here. But the Fraser River is not the only river in the Salish Sea, and there are a lot of smaller rivers that are all contributing to the freshwater budget of the Salish Sea. So with that being said, off the land, we have all of this fresh water that enters the Salish Sea, and with it, whatever is in the fresh water is ending up in the Salish Sea. At the same time, we have deep water entering from the Pacific Ocean. This water is cold, it's salty, it's heavy, and it has a lot of nutrients in it. And all of this is coming from coastal upwelling. Now, coastal upwelling and downwelling refers to the movement of deep water and water in general up and down, respectively. So in the northern hemisphere, winds blowing parallel to the coast from the north cause water to move away from the coast. This pulls up deeper water to replace it. This is upwelling. And so what is so special about this deep water, like I previously said, is that it is full of nutrients. And nutrients are really important for the organisms that call this place home. So we have this fresh water and we have this cold, salty water. And fresh water is less dense than salt water, so it's going to sit on top. And the same is true of warm water. It is also less dense than the cold water. So this differences is going to create stratification in the water that is in the Salish Sea. So here in this glass, we can see this fresh water sitting on top of salty water. So to return to our diagram here, we have all of this fresh water that's entering off the land, this deep, cold water that's coming in through primarily the Strait of Juan de Fuca that is full of nutrients. And this is going to drive the circulation of the Salish Sea. So we have this warm surface water leaving and this deep water full of nutrients entering.
So thank you, Sadie, for introducing all of the physical aspects of the Salish Sea. I will sort of briefly talk about how that influences the biology. So as Sadie discussed, the land to sea connection is a key feature of the Salish Sea. It determines the circulation of the waters and all of the fresh water that enters the marine environment, which brings along with it these nutrients like phosphorus, nitrogen, and iron. So this input, this massive input that comes off of the land is highly seasonal. So it's very dependent on high sunshine. And when you have this combination of high sunshine and nutrient supply, this drives the growth of phytoplankton. So what are phytoplankton? Some people have heard of this species, some people have not. But basically, phytoplankton are these microscopic species that live on the surface ocean. They are responsible for creating nutrients for the base of the food web that exists in the marine environment. And they are dependent on these features. They're dependent on light, nutrients, and optimal temperature to thrive, to grow, and to create conditions for success. So phytoplankton are the foundation of the food web. Without them, the rest of the food web would not be able to survive. They ultimately provide most of the food that supports our ecosystems, all the way up to fish, which we know is very important economically, culturally, and for our food supply for a lot of people around the world. They produce 50% of the oxygen that we breathe. So through this process, they're creating oxygen. And on this West Coast, we often think of trees as being the biggest producers of oxygen. We're always trying to think of that and protecting our forests. But it's very interesting to know that phytoplankton is actually responsible for producing more oxygen than trees. So they're a very vital part of our ecosystem. And they also remove CO2 from the atmosphere, which is very important in reversing or at least combating the effects of global warming. So they are responsible for the estimated average is 60% of anthropogenic sources of CO2 are being consumed by phytoplankton. So how do they do this? Maybe some of you have heard of photosynthesis by learning this through school, but phytoplankton are basically the microscopic plant species of the sea. Similar to how photosynthetic organisms behave on land, they go through the same process. So using the energy they harvest from the sun, they intake carbon dioxide and through this process create glucose and oxygen. So that's what they use as their energy source. They use this by a pigment called chlorophyll, which is also used by plant species on land. And as well as this light source and this carbon dioxide, they also require these nutrients, like I mentioned. So nitrogen, phosphorus, and iron. So you can think of these things coming off the land that come from agricultural practices, any sort of nutrients needed to grow plants on land. When those end up in the marine environment, they influence the phytoplankton in the same way. This is an image here of phytoplankton, and it's just to give you perspective of how diverse this class of species really is. You kind of just think of something microscopic, but it's so diverse. There are thousands and thousands of species of them. And 1 teaspoon of seawater can contain as many as 1 million single-celled phytoplankton. So it just really puts into perspective how many and how diverse they really are. Just to put their size into context, you can see here a variety of different phytoplankton species, from the smallest being the Chlorococcus, all the way up to a large species of phytoplankton, the Trichodesmium. And for size comparison, the smallest would be relative to the size of a fish, whereas the largest would be comparable to the size of Manhattan. So again, this just puts into perspective how different this whole class of organisms is, where we kind of see it as unicellular or uniorganism. So again, although they are invisible to us, phytoplankton are extremely unique, very diverse, and they're the foundation for this marine food web. So they're an extremely vital part in making sure that the rest of our ecosystem is thriving and surviving. So it is very important to consider the bottom first when you're looking at how it will ripple up and affect the rest of the web. Here we can see a couple examples of different phytoplankton species, just so you can have a closer look at some of the imagery that people can collect now using microscopes. So this is an example of a phytoplankton species called diatoms. These are very common in Salish Sea waters, and they're responsible for a lot of the food supply for a lot of higher level organisms. They have cell walls made of silica, and this is an important nutrient that they need to acquire from their environment. Here you can see some dinoflagellates. This is a separate class of phytoplankton. One that maybe some of you might be familiar with is called Alexandrium. So this dinoflagellate specifically is responsible for a paralytic shellfish poisoning. This is when shellfish such as mussels, oysters, and clams consume the dinoflagellates, which then causes saxitoxin. And when humans consume that, it's toxic to us as well. So this is why sometimes around the Salish Sea, there are warnings to not eat the shellfish. And it is because of this proliferation of dinoflagellates. But on the other hand, you have some amazing species of phytoplankton responsible for the sea sparkle, the Nauticula scintillans. And this creates the classic example of bioluminescence that you can see in the night sky on our coasts. As well, another example is coccolithophores, and this is a huge bloom happening on the west coast of Vancouver Island that you can see by satellite. You can see this large plume here. So there's an annual coccolithophore bloom off the west coast, and it's quite extraordinary. And this is just to say that, again, there's a huge diversity of phytoplankton in the marine ecosystems, and depending on this amount of light, nutrients, and other physical conditions, certain groups of phytoplankton can dominate over the other. So here you can see over time and different classes of phytoplankton. What I want you to look at is just the fact that how much it's changing over time and the seasonal fluctuations we have. So the amount and types of phytoplankton change seasonally, which is going to drive what is eating them and when. And this is often because of that land-sea connection we discussed and when the fresh water is entering the marine environment. So typically in winter, there's a lot of mixing, there's not very much sun, and they don't have the right conditions for phytoplankton to thrive. So it's quite low abundance in general. And then when you move into springtime, you'll get that very nice warm water in the upper layer of the water column. And as well, those high nutrients end up being trapped in that area. With the increase of sun, this is creating the perfect conditions for a phytoplankton bloom. It's exactly what they want for survival. So this is encouraging those blooms, which is why throughout the year, we do have a large spring bloom happening. And then later, as the season continues, all of the nutrients are consumed by phytoplankton, and then they will decrease again. So we do have these strong seasonalities of different phytoplankton blooms. And this is just to show that this is a temperature range across a year in the Salish Sea. And you can see this big plume here is just a low temperature in the springtime. And that is an indication of all this fresh water that's just coming off of the land with the rainy season. And bringing along with it is all of those nutrients that are going to support these blooms. So there are a lot of threats to phytoplankton in the Salish Sea, and this region is experiencing a lot of changes driven by climate, change in temperature, freshwater inputs, and acidification. And this is also a very human-dominated ecosystem. So there's a lot of pressures coming from urban development and different areas. And this phytoplankton, again, is influencing the rest of the food web. And eventually we are seeing in the Salish Sea declines in certain fish populations. And it is something to consider that we need to look at all aspects of the food web, including phytoplankton, to create a better story of what's actually happening here. And it's just to say that oceanography is very important to the food web. All these physical conditions will really drive the biology. And what's important to take away is that our environment is all interconnected. What happens at the base of the food web will have a rippling effect to all of these higher organisms, including us.
Thanks a lot, Tasha. Just moving on now to talking about the rest of the food web. I'm just going to quickly summarize the key points of phytoplankton. They're microscopic organisms. They come in diverse forms. And their efforts to capture the carbon dioxide that we see in the atmosphere effectively combats global warming and also produces a lot of the oxygen we breathe. But one of the things that kind of serves as a tagline for phytoplankton is that phytoplankton are the foundation of the food web. And I wanted to kind of get into that a bit more and kind of clearly outline what that really means to talk about the rest of the food web. So we can return back to this food web that we saw earlier. And you notice the black arrows that connects all of the species together. In this specific diagram, this is just a reference to the transfer of energy. And in a food web like this, the energy transfer is facilitated by consumption. So the next level trophic species that would want to obtain the energy produced by phytoplankton would have to consume that phytoplankton, and they would next serve as food for the next set of species. And this would eventually drive that energy transfer up to the top level consumers, including us humans. So in other words, phytoplankton serves as this foundational food source in the food web. But we're going to go into specifically looking at that next step into zooplankton, because they are separate, although they have similar names to the phytoplankton, they are separate and also serve a critical role in the ecosystem. So plankton is the suffix here. Plankton just means free-floating species that live by the current. They don't have directed swimming abilities. And zooplankton are this great, widely diverse set of species that serves as a critical food source for a lot of the upper level trophic species. So I can go into the level of diversity by looking at one type of zooplankton. These are copepods. They're marked by their distinctive 2 antennae that's poke out at the top at the top side of their bodies. And copepods have over 10,000 species. So that just puts into perspective how widely diverse the zooplankton species set can be. One that you might be more familiar with is Euphausia or krill. These are species that small crustaceous species that like to aggregate into large pools or schools together. And I'm sure you're all aware, like they're also food for many organisms like whales as well, who like to eat krill. And there's also other animals that you might have not expected that also live in this world of zooplankton: squid larvae, the sea star larvae, and also many species of fish like this herring that you can see at the bottom of the screen. These are all species that at some point of their lives during their life stage, they are zooplankton as well. But again, like I was saying earlier, zooplankton are this key food source for many species, and this also includes the Salish Sea. This includes market squid, the jellyfish, many juvenile salmon species, shellfish, including mussels, clams, and oysters. And also Jess had mentioned in the early presentation the importance of forage fish. These forage fish are also top predators of zooplankton as well. They rely on zooplankton to obtain their energy, and forage fish are critical small fish, and I think Jess referred to them as bait fish, that serve as food for a lot of the larger fish species in our oceans. So coming back to this food web, we can see that phytoplankton, this energy transfer, the main role that zooplankton have is transferring that energy from phytoplankton over to zooplankton, and this would then get facilitated and moved down to the rest of the food web. So zooplankton are critical for connecting the energy from microscopic species up to the small fish. And this is overall in an effort to obtain the energy from the sun to transfer it all the way down to the top level consumers, in this case, whale, but also this applies to us humans as well. So a large theme here is that the marine food web is very, very interconnected. Like Tasha had mentioned about the rippling effects, things that change at the base of the food web can have implications that work upwards into the food web as well. Every single one of these species in this food web play an important role, not only mostly for for other species, like of other individuals in their species set, but also the other species in the food web as well. We can look at a bit of a more complex food web here. The arrows in the middle, this refers to a herring life stage, and you can see how other species in the marine environment also rely on herring as a food source throughout their life stage. And this green circle here that you can see that's centered, that surrounds the plankton in the middle, is showing how energy is being transferred throughout the food web. The energy is sourced from the plankton, and it gets transferred to the pelagic fish, the whales, the benthic fish, up to terrestrial animals and birds near shore. And I wanted to actually direct our attention to these species that are living on the land. Even though this energy is sourced from the ocean, from the plankton species, birds near shore, terrestrial animals can also rely on the marine environment for their energy as well. And this comes back to our theme about how the land and ocean is strongly connected. There is ways that the land can influence the oceanic environment. There's ways that the oceanic environment can also influence us in land. And there are ways that we are contributing, the ways that the land obtains energy from the ocean just as much as the ocean obtains energy from the land. When you look at this food web, I'm sure some of you may wonder, we are missing one important piece, part of this food web. I'm sure many of you can kind of guess what it is given the topic of the rest of our presentations. And it's humans are also very involved in this energy transfer, and they're just as deserving of this green circle of energy that gets transferred throughout the food web as much as any other species in this diagram. And humans, similar to this land-ocean connection, humans are very responsible for dictating and influencing both of these bodies and their relationship. So this provides a good leeway over to our discussion of urbanization of the Salish Sea and our discussion of key features, impacts, and research directions. So we introduced the idea of an urban ocean. So we want to just kind of quickly define what an urban ocean is. So we define it as an area where a high human density area interacts with the coastal ocean. In the context of the Salish Sea, over 8 million people live near the Salish Sea. And this includes the two major cities of Vancouver, British Columbia, and Seattle, Washington. And you can see in the bottom diagram here that this land-ocean connection is impossible to consider without thinking about how people are involved, because again, all of these separate pieces are influencing and affecting each other to some degree. So we could provide a long laundry list of different things that the urban oceans, how urbanization can affect the Salish Sea. We're going to kind of just break it down into three general ones, acknowledging the fact that there are other ones that we haven't mentioned. So one is changing the physical landscape. We're going to show later a link to a stormwater story map, and it demonstrates just how Burrard Inlet, the inlet near Vancouver, British Columbia, has completely changed since human contact, due to industrialization and building new shorelines and changing the shorelines and things like that. So one key feature is how the physical landscape can change due to human involvement. And the next one is pollution. We saw a lot of people in the chat mention wastewater pollution, plastic pollution. That's a very important and key piece of the human influence and how humans are connected to the ocean as well. And another one is industrial activity. A number of industrial sites here in Vancouver are right beside or right adjacent to the Burrard Inlet Ocean, as you can see in this image here. So I'm going to give it back to Tasha to talk about the urban Salish Sea.
Yeah, so a little bit about the urban Salish Sea. So there are over 700 contaminants that have been measured in Burrard Inlet alone, which is quite substantial. And there are 11,000 vessels that move through the Salish Sea annually. It is one of the busiest ports in North America. There are 375,000 acres of impervious surfaces in the Puget Sound alone. So here you can see in this map here, it is just the Salish Sea showing all of the impermeable surfaces. So anything that's like a hard surface. And this is becoming an increasingly big problem we're finding out in the Salish Sea because it allows for a lot more of the runoff to be entered into the ocean environment. Before these places became highly populated with cities and impermeable surfaces, contaminants and things that were coming from people would end up being leached into the soil or would remain in place. But now because of this hardening of these shorelines of streets and buildings, everything just eventually ends up washing away into the sea. So this has become an increasingly big problem. And on top of that, there are 78 US and 9 Canadian wastewater treatment plants that are all emptying out into the Salish Sea at once. So there's a lot of stressors happening here. So how does this impact the biology? How does it impact the marine environment? So there are a lot of examples of this. Some of them to note are that there are dams that prevent spawning of the salmon so that they cannot go upriver. The pollution that's contaminating the fish and the shellfish that we can no longer eat for human consumption. There are harmful algal blooms that are causing fish die-offs, E. coli outbreaks that create unsafe swimming conditions, and as well, a lot of boat traffic affecting whale echolocation, so noise pollution. And we don't say this to scare anybody to say, oh, look at all these bad things happening. It's just some of the stressors that come with a city and an urban environment we need to consider. And it's important to consider what the stressors are before we can work to solve the problems.
So I'm just going to talk about a case study, and I saw that a number of you had mentioned stormwater. I think I may have even seen someone mention 6 ppd, and I saw another question about salt. And so I have this urban impact case study of stormwater. And in the first half of the talk, I mentioned how much fresh water, how much rain is coming off of the land. And like Tasha mentioned, we have this hardening. So all of that water that's coming out of the sky is hitting impervious surfaces, and it's flowing through human-made infrastructure. The amount of water isn't changing, but how it's moving through the environment is. And with that means what it's carrying, what it's containing to our sea is now different. So here I have a map that's that was made by the Nature Conservancy for the Puget Sound. That's a stormwater heat map to show where and how much this stormwater is moving into the Salish Sea. So here it's total suspended solids is a measure of stormwater contaminants. And those bright yellow areas, those highly urban places have a lot of impact. And the same is true in Vancouver, locally in Victoria as well. And so we really need strategies that's gonna minimize the impacts of stormwater. And like I said, why we care about this is these harmful chemicals, such as a tire residue compound known as 6 ppd 9-quinone, it's been linked to killing salmon, juvenile salmon, in their rivers as they hatch the eggs. And that's not great for salmon that, orcas rely on and people rely on for food. And so rain gardens were mentioned. All of these were mentioned as a solution. And so we need solutions to problems like this in the urban environment, because the nutrients that come from stormwater are going to impact the phytoplankton, which is going to impact the zooplankton, which is going to impact the herring, which is going to impact the salmon, and which is going to impact the orcas. So it really is all connected from land to sea to us. And it starts with these solutions to urban problems. And so what does the future of the Salish Sea look like? We're going to see a higher population just for a variety of reasons. And with that means there's going to be more surface hardening. And that means more urban impacts, not just of stormwater, but of industry, of boat traffic, of all of these things that we have mentioned. And all of this is going to be compounded by climate change. And this isn't to paint a gloom and doom situation. This is just what is happening. And climate change is predicted to mean that we're going to see higher, larger rainfall events interspersed with droughts. And what that means is that all of this material is very quickly going to get washed off by rain and end up in our sea. So we are all here because we care about where we live, and we are responsible for how this land is being used and how this land is being cared for. And as Jess mentioned, you have a voice, so use it to enact change. Use it to vote, to be active. For example, here in Vancouver, there's currently a project to separate sewers from storm. So previously, all the stormwater and all the sanitary waste has ended up in the same pipes, gone straight into the ocean, which isn't great. And they have working on separating it so that sanitary waste is now being treated, but all of that stormwater is still going into Burrard Inlet. And so a really great thing while they're replacing these pipes would have just been to also treat that water and put green water infrastructure in. And so that is one example of a place that we can have an impact, that we can make it known that we're not okay that they are doing this, we can't swim on our beaches, we can't eat our shellfish. And similar things are happening to our neighbors down south. And so being aware of what is allowed in the water is really, really important. And so now I'm going to pass it over to Dilan and to talk a little bit more about our specific research with the Urban Oceans Project.
Yeah, thanks a lot, Sadie. Yeah, so this is just a quick elevator pitch of our Urban Oceans project. I'm just going to be kind of going over some general research questions and then some of our tools that we're using to answer these research questions without going too much into the sciencey specifics. This is specifically in the context of Vancouver's urban ocean. We're wondering about what species are there and how specifically are they distributed. And we can use environmental DNA, or what is more commonly referred to as eDNA. None of us here are experts with eDNA, but just very quickly, every species, marine species, they shed a bit of their DNA into the water. So through some water collections and some lab work and analysis, you can actually pick up and understand how and where species are being distributed. And this is one of our primary questions, because we want to know if species are existing and still being able to live and thrive in very disturbed areas in Vancouver's urban ocean. Another one is considering the species health and how does it actually compare to non-urban areas. And we use biological tracers. So one of them is fatty acid analysis. Another one is stable isotope analysis. So these are just two different chemical techniques that we can use where we collect, and the species that we're mainly prioritizing are mussels. So we collect mussels around Vancouver, and we conduct fatty acid and stable isotope analysis just to have an idea of how their health is doing compared to the non-urban areas. And another one is, what are the chemical profiles of urban inputs? We talked about stormwater, we talked about wastewater. Here in Vancouver, there is minimal public data out there about what the chemical profiles of these urban inputs are. And it's important to know what this looks like before it ends up in the ocean to be able to assess what are potential hotspots. Are certain pollution areas more threatening than others? So that's why that's one of our priorities, is to isolate these urban inputs and understand what their chemical profiles look like. And we use various organic chemistry techniques to do this. Just to talk quickly about some of the images you see in the corner, the bottom left one is our filtering apparatus. So what we do to understand what the water profiles look like, we collect water and then we have to run it through a filter, and we have all of our collection material that we want to work with in a small filter that we end up just freezing, and then we conduct our lab analysis later. The photo in the middle is a zooplankton bongo net. So this is what we use to collect zooplankton in different parts of the ocean. And the image in the far right was one of our night sampling days, where we collect the water right off of a bucket, and then we end up pouring them through labeled containers, and then we end up taking them back to the lab to do our filtering. We have many collaborators that work with us. One of them of which is the Tsleil-Waututh Nation. That is one of the standing nations here in British Columbia. And I wanted to just go into a little further about their influence in their work for restoring Burrard Inlet. So Tsleil-Waututh Nation is a distinct coastal Salish nation with an extensive traditional territory. The image you see on the right is their consultation area. This doesn't represent the full extent of their traditional territory, but it does show where they're prioritizing their research efforts. In Hunkaninam, which is the traditional language of the Tsleil-Waututh, the Tsleil-Waututh means people of the inlet, which illustrates their deep ancestral connections to the land and waters of Burrard Inlet. The Tsleil-Waututh people have a sacred obligation to be caretakers and protectors of the inlet. This responsibility guides a lot of their work today as they try to restore the health of the inlet after colonial impacts that have eliminated meaningful opportunities to practice many of their inherent and constitutionally protected rights. Some of their key species that they focus on are birds, salmon, herring, and clams that the Tsleil-Waututh are actively working to protect and re-establish. On the far left, you can see an image of the Burrard Inlet Action Plan. This is a science-based, First Nations-led initiative to improve the health of the Burrard Inlet ecosystem by 2025. In the middle, you can see a screenshot of a website that I mentioned earlier, the Stormwater Story Map. It's titled Restoring a Healthy Inlet. And I have a QR code that I've included at the bottom of this slide as well that takes you to this webpage. It is a beautiful summary of the history of Burrard Inlet, what the conditions are now in a First Nations-based perspective, and also talk about future projects and also go into what we can do as a community to help with restoring the inlet as well. So I strongly encourage everyone here, if you have the time, it is a beautifully put together webpage that kind of goes over many aspects of Burrard Inlet, especially in the context of both stormwater and more generally urbanization. With that, I want to thank every single organizer for this talk, and I want to thank my two colleagues, Sadie and Natasha, for supporting and being awesome presenters. And thank you everyone for taking the time to listening to us today. We're happy to accept any questions.
Great. Thank you so much, Dilan, Sadie, and Natasha. That was amazing and very informative. And I think a great start in addition to Jess's talk about the kickoff to our Wonders of the Salish Sea.